Let's start with the 21st question. A body is executing simple harmonic motion with frequency n. The frequency of its potential energy is. So we obviously know that in case of an SHM, the value of x is a sine omega t. So the value of potential energy is half kx square, which basically means half k a square sine square omega t, which makes it a function of cos 2 omega t, which means the frequency is 2n, double the frequency of the SHM. Okay, double the frequency of the SHM. Let's come to the 22nd question. An inductor of inductance L, a capacitor of capacitance C, and a resistor of resistance R are connected in series to an AC source of potential difference V volt as shown in the figure. Potential difference across L, C, and R is 40, 10, and 40. So this is 40, and it is written over here 40, 10, and 40. Find the amplitude. The amplitude of the current flowing through the LCR circuit is 10 root 2 amperes. Amplitude means the peak value, and it is equals to 10 root 2 amperes, which basically means the RMS value is I naught by root 2, basically means 10 amperes. All right. Now we know that the phasor diagram for VR is like this, VL is like this, and VC is like this. So this is 40 volts. Now this is 40 volts, and this is 10 volts. All right. So if we solve this phasor diagram, we will get 40 over to this side and 30 over to this side, which basically means V net is equals to under root of 40 square plus 30 square, which comes out to be 50 volts. Now the value of impedance is equals to V RMS divided by I RMS. Basically means 50 volt divided by 10 amperes means 5 ohm. So the value of this answer is, the correct option is 5 ohms, the third option. All right. Now let's come to the 23rd question. And the electron concentration in a N-type semiconductor is the same as hole concentration in a P-type semiconductor. An external field is applied across each of them. Compare the currents in them. See, we know that the mobility of electrons is much greater than the mobility of holes in semiconductor. Now, which means that drift velocity of electrons is much greater than the drift velocity of holes. So now the current due to electron is NEAVDE, and the current due to holes is equals to NEAVDH. Now obviously this value is greater than this value, which makes option 2 the correct option. All right. Come to the 24th question. The half-life of a radioactive nuclei is 100 hours. So we know that the half-life is 100 hours. Now the fraction of the original activity that will remain after 150 hours would be, now the value of activity is equals to simply a naught e to the power minus, now we can write lambda t. All right. Now after 1.5 half lives, see 150 hours is 1.5 half lives. The value of original number of carriers or the original number of atoms, radioactive atoms in the sample, becomes n naught divided by 2 to the power n, which means 2 to the power 1.5. So which makes the new activity equal to a naught divided by 2 to the power 1.5, which means a naught by 2 root 2. This basically means that A dash by A naught is equals to 1 by 2 root 2. All right. So the correct option for 24th question is the first option. All right. Let's come to the 25th question. The number of photons per second on an average emitted by the source of monochromatic light of wavelength 600 nanometers, which is when it delivers the power of 3.3 10 to the power minus 3 watt will be. So obviously we know that power is equal to number of photons multiplied by energy of one photon, right? Now, what is the power? It is equals to 3.3 into 10 to the power minus 3 in SI units is equals to n times. Now, what is the energy of one photon? It is hc by lambda. The value of h is 6.610 to the power minus 34 times 310 to the power 8 divided by lambda, which is equals to 600 multiplied by 10 to the power minus 9. We have to convert this in SI unit. Now the value of n, it is coming out to be 10 to the power 16, which basically means the second option is the correct option. Let's come to the next question, 26th. A thick current carrying cable of radius r carries current T uniformly distributed across it cross section. The variation of the magnetic field B as a function of R due to the cable with a distance R from the axis of the cable represented by. See, when R is less than R, let's say this is the cable and its radius is R and current is constantly flowing through it. Now, if we take an Amperian law loop over here, we will get that the current, or rather the magnetic field, is proportional to R, and when we get R greater than R, the value of magnetic field becomes inversely proportional to R. So this is the variation of magnetic field that you should know. So this makes the option 2 as the correct option. Now 27th, for a plane electromagnetic wave propagating in x direction, which one of the following combination gives the correct possible direction for the electric field and the magnetic field? Now we know that electric field is always perpendicular to magnetic field. Now, if this is the component of the electric field vector and the second component is of the magnetic field vector, their dot product should be same, which means the dot product should be equal to 0 because the angle between them is necessarily 90 degrees. Now this is possible only in the first case. If you check, minus j dot j becomes 1 and k minus k becomes minus 1. That becomes 0. So 27th option 1. Now 28th question. A parallel plate capacitor has a uniform electric field E in a space between the plates. Now the distance between the plates is d and the area of each plate is a. The energy stored in the capacitor is, now if you have to find the energy stored in the capacitor, you just need to apply the energy density formula, which means energy stored per unit volume is equals to half epsilon naught E square. So what is the value of U? Half epsilon naught E square multiplied by volume of the capacitor, which makes it AD. So the correct option is the second option. Now let's come to the 29th question. Consider the following statements A and B and identify the correct answer. A Zener diode is connected in reverse bias when used as voltage regulator. Now this is the true statement. Okay, because Zener diode is used to regulate the voltage and it is used in reverse bias configuration. Now the potential barrier of the PN junction lies between 0.1 and 0.3. No, because it is round about 0.7 volts. So A is correct and B is incorrect. We get option 2 as the correct option. Now question number 30. A screw gauge gives the following readings when used to measure the diameter of wire. Main scale reading is 2 millimeters and the circular scale reading is 52 divisions. Now obviously the reading becomes 0 millimeter multiplied by least count of main scale plus 52 divisions multiplied by least count of circular scale. this, the first term becomes 0 and this becomes 52 times 0.01 centimeters, which basically means 0.52 centimeters. Okay, and this is the correct option. So we get question for question number 30, we get fourth option as the correct option. All right.